Given this function f of x, we're going to answer the following questions, and it says use exact values. First thing, it says to find the first derivative. So we can see that we have a quotient, so we're going to do a quotient rule. We're going to take the bottom times the derivative of the top, which is 7, minus the top, which is 7x, times the derivative of the bottom, which is 2x, all over the bottom, which is x squared plus 5 squared. So that's the derivative. We can do a little bit of simplifying, and we'll go ahead and do that. And so distributing the 7, I've got 7x squared plus 35 minus 14x squared over x squared plus 5 squared. Let's go ahead and combine the like terms then. So it looks like we get negative 7x squared combining these two x squared terms, and then plus 35 over x squared plus 5 squared. So this is the derivative. Now it wants to know the intervals where the function is increasing and decreasing, and then we're looking for local maximum and minimum in a minute. So I'm going to figure out the critical numbers, and I'm going to put them on a number line for the first derivative. Remember, critical numbers come from what values that would be undefined, make the derivative undefined, or that would make the derivative 0. So as I'm looking at the derivative here, the denominator is always positive. This is an x squared, so you'll be adding things to 5, not taking away. So the denominator will never be 0, so there won't be any places where it's undefined. So the only places where there are critical numbers would be what would make the top 0, because the top of a fraction equaling 0 would make the fraction 0. So we're going to take the top of the fraction, put it equal to 0, and solve it. We could move 7x squared to the other side. 35 divide by 7. So that means x squared would equal 5. I'm going to put it back over this way in the interest of room. So x squared equals 5. So x equals plus or minus the square root of 5. We've got to remember to always put that plus or minus when we're solving an equation in square root. So as I go down my number chart, I have a critical number at negative square root of 5, and I have another one at square root of 5. These are places where that first derivative equals 0. So now I need to test numbers on all of these intervals to find out if the first derivative is positive or negative there. I'm going to test 0. So I put that in the first derivative, which I've got boxed in right here. And if I let x be 0, I can see that in the numerator I just have 35, and in the denominator I would have just the 5 squared, and so it's going to be positive. And let's test something. Square root of 5, well, square root of 4 is 2, so square root of 5 is 2 point something. So let's go ahead and put in something we know is bigger than 2 point something, so let's put in 3. So if I come back up here and put in 3, 3 squared is 9 times negative 7 is negative 63 plus 35. The numerator is going to be negative. The denominator is always positive no matter what you put in there. So a negative divided by a positive will be negative. Now I'm going to test negative 3, and I can see I'm going to get a negative again because I'm squaring it, so it'll end up getting the same answer I had when I put in a positive 3. So there's my sign pattern. Now I'm ready to answer the questions, and I've put stuff in my way for where the intervals were, so I'm just going to put it down here below. Intervals where the function is increasing would be anywhere this first derivative was positive, so that would be from negative square root of 5 to square root of 5. And decreasing would be the other intervals, negative infinity to negative square root of 5, and then also from square root of 5 to infinity. So we've got part B answered right here, the intervals where it's increasing or decreasing. And then it asks for the exact x values for the local extrema. Well, looking back at my sine pattern, I was decreasing here and then I'm increasing, so that would be a local minimum. And on this other side, I was increasing and then I was decreasing, so that would be a local maximum. It didn't ask us to find the points, it asked for the x values. So f of x has a local maxima at x equal square root of 5, and it has a local minimum at x equal negative square root of 5.